E doar un vis frumos care se tot repetă și doar în visul meu găsesc lumea perfectă. Nu
Alright guys, I hope this works. Let's actually see that.
Sancă zbor și culmea n-aveam avion când dintr-o dată mi s-a stins sigara, m-am trezit pe băteam la ușă ca să ajung în dormitor și mi-a deschis o pistă bună, ai un foc că mor. Visam că trec peste mări și țări, că pot să schimb vorbe cu flori, că vorbesc în diferite culori. Visam că sunt falin și că mi iubesc țara, că n-am un leu în buzunar și că nu-mi trebuie para. Visam că bag ea în contact și mă îndreptam spre impact. Știam că rabla revoințea vrea copac. Visam că am gagic sau cam așa ceva, dar ei se beau sus în hamacul tău pe muzica mea. Visam că Doamne, Doamne mă veghează, probabil când ăla ciordea din casă nu era pe fază. Visam că pot să schimb lumea și credeam că pot. Visam că fac rap și eram tare de tot. Visam că vând albume mai bine ca pâinea caldă, că fumam iarbă pe stradă cu toată lumea de la gardă.
Why is this so complicated?
Zi și o seară mortală, degeaba stingi luminile, aici e beznă totală. Doar un
vis frumos care se tot repete și doar un vis frumos găsesc lumea perfectă. Okay, why is this so hard actually? Okay, great. So what we're trying to do here is basically, so VRE is a batched data pipeline kind of library for machine learning for multitasking. So basically, if you have a video, you can get various outputs like semantic segmentation or depth estimation or others like action recognition and so on. But this works at the video level, so basically you get like a list of frames and then you output all the representations and then they are stored on the disk and then you can do stuff with them. So it's more like a batched approach, like stuff, so it's something like this: video representations, store on disk, representation, frames, it's a list of frames, read each frame's prediction. This is a bit tedious for streaming applications. It's batched, right? So what we want in a streaming one is something like video, list of frames, predictions in memory, something like this. And right now our streaming implementation is something like this. It's kind of piggybacking on this, so it's basically this, to be honest. Predictions in memory, store on disk, each representation on temp, and it's something like this. So I want to stop storing on disk, stop reading again, because that's like slowing down the process, and what I want to do is to just do this. So how it's done today is basically, so I copy pasted this get item. So the get item itself here should be the same, so I shouldn't change anything, but only this is the implementation. It's very easy, right? It's pretty much copy paste from the main batched for loop, which is like around here. Not there, it's on run here. So this just does a lot of setup and then it just calls to one representation and then just some set stats. So I copied that in this function which I call get item 1, which is exactly as I said. So I do each representation and this outputs to an output dir. I have this run ID, which is like a unique ID, which is temporary, right? I have a temporary run ID. A temporary directory. Yeah, so basically I think I can even move this. I use the output here anywhere. No, I don't. I can even do this. So I can instantiate this stuff here. right? So this is the implementation, but as I told you earlier, like it stores on disk, you read them from the disk, and it's like a bit not nice. You can make images at the end, so I want to streamline this a bit better. Now first, let's see if it works. Alright, so did something here. Oh, I removed this part for no reason. Alrighty. Yeah, so you have like a video, you have a bunch of frames, and you just want to get item. And yeah, now for the representations, I have a bunch of the implemented already. So RGB obviously is just reading the frame. Now, if I recall correctly, I need to put name and dependencies. I don't like that it doesn't show here, but yeah, I know. So like a name, because you can have in theory the same representation multiple times, different parameters. And dependencies, this is just an empty list. I kind of force you to do this every time, so like you don't get weird defaults. And then save UAV, just semantic segmentation that I work on. Now even here, like this disk data argmax is maybe not something that should be here. So the parameter, so this is not yet like a finished product for sure. So this is an implementation detail for how to store the data on disk and how to load it. So that means, because for semantic you have like 3 options to store it, and it's a bit I kind of support all of them, because in some cases you just get predictions from some other parts and you want to interact with this. Some cases you get raw predictions, meaning, so what I mean is that for semantic segmentation you have something like this. Let's see, have 3 options. So you can get, so let's say that you have 3 classes, cat, dog, giraffe. It's giraffe. Yep. So ways to represent. So you have the classical one. I mean, for sure you can represent it as a string. So prediction. String. Cat. Now this is like you need a language model or something similar for it, and it's not very efficient. Now people have been using one hot, which means so let's assume that cat you store it as like this, as a vector, so 1 to the correct prediction, 0 anywhere else. But you can also store it as 2 other ways. So this is nice because you can store it as an index, which is 0 out of 2. And this is disk data argmax, by the way, which is the argmax of the one hot. Argmax of one hot. And you can store it as raw probability, which is 1.0. So this is maybe 0.32, flow 32, and you can also store it as logits. Raw probability after softmax, or it means for softmax, which is can be like a number. This is just the internal, so maybe let's put like 15 minus 3 minus 99, flow 32, internal to each mod. So after your softmax you get a probability distribution, so maybe I can put it here, 0.98, something like this. Maybe let's do it like this just to be. So you have all these options, and now we support so basically one hot and logits and probabilities, like all of them are kind of probabilities. Now this one is not normalized, but still you can argmax on any of this and you will get this. So argmaximum auto should yield index every time. Right? Because they are they're basically monotonic. So that means if you apply a transformation from this to this, and softmax is a monotonically increasing function, and like you don't change the order. So argmax is still argmax basically. This is still the maximum position. Yeah. So this first parameter means, okay, how is the data stored? But obviously we don't really care how it's stored. Now I have another issue with this, is that the compute function, which is where is compute? Here. This is very dependent on each representation, so you don't really know how it's stored in memory. You just know that you can later store it on the disk with argmax or not. So yeah, this is a bit annoying, but it's just a small detail. Now I know that Safe UAV outputs the data basically in the, I think output data is in softmax, something like this. If I recall correctly, because you have decoder, have out channels. I don't have any softmax here. No, there's no softmax in the logics. But anyway, I can actually look at how I make the images. I guess make images. Where is make images here? Make images, colorize. Okay, so your argmax, so you assume that you get it as logits or as softmax, but you don't know which one, right? And this is where I do this transformation, but as you can see, it's not perfect. So I ideally would not need to specify this data argmax explicitly, to do remaining a way to specify memory data format one hot softmax logits index. So we have this concept of memory representation. Yeah, let's stop this, or let's put something that doesn't have lyrics. So we have this concept of memory data and disk data, right? And you can, so the idea is that on disk you store the data in some way, and on memory you may keep it in another way, and you want to have this transformation between one and each other in order to basically maximize performance. Because it may be fine to store the data as logits in memory, but when you store it on the disk, because you store it as like float 32, and you may have like, I don't know, 100 classes, you need to store 100 floats for each pixel, and then you have like 4K images, so each prediction has like a few megabytes or tens of megabytes, and that's not efficient. You store it as an index that's like 32 times smaller, so you can like read it faster. So yeah, it's basically, this is a way to manage storing data on disk and storing data in memory, and being able to go from one representation to the other and kind of not lose as much, or at least have a way to control the data. Also can store it as float 16 so in some cases, but this only makes sense for this data argmax false, because otherwise you store it as uint 8, but this is also not necessarily good if you have more than 255 classes. So you can see like there is a bunch of gotchas that are not perfect, but for now I didn't get into any of this. We have only 8 classes in Safe UAV. So this is obviously smaller than 288, so we don't care about that. So okay, let's move on. So this is why you have this parameter. Now this parameter doesn't really matter, because I don't even want to save the data on disk anymore, so I can just put it here. Actually I need to specify this RGB doesn't need to be specified, it's implied. So in theory you could say RGB here, but you shouldn't. This data max equals false and variant equals, I think it's for 30k. It's for 130k parameters, 1000 parameters. We have a bunch of variants that are implemented. Variants. Yep. And I have even a smaller one. Let's do the smallest one. Let's not say if is smaller. Okay. But this should be our representations. That means theory I should be able to do this to graph this. I want to see it. I think I got an error about that. So to graph this, nice is display. Render. Hold up. No, render. Oh, there you go. To graph is render. Alright, very nice. Alright, and just put it here like graph. Alright, and so exit 0. Or actually just exit 0. So in theory this should work. Let's see. Example, do the streaming. I think there's something broken here. No, it's not. It should work. Pipe operators need to be in the right environment. Ah, shit. Dot. So I don't have dot. That means I need to install dot. In order to install dot, do I have anything ready for that? So I move my shit on the web. Now let's see if I have anything about that. Graph this. Anything about graph this here. Alright, I think I can install it just like this. Hopefully. Dot. Dot Ubuntu. Graph this. Oh. For that name. So this should be a list of representations, so I get some sort of representation, which should put here. So now I get some syntax highlighting for it. Alright, let's see if I get that working. I mean, it should be working, so I can read the video, and then this should store it. I should have just two representation, RGB and CFEV, no dependencies between them. That's fine. Now in theory I could use this, but I didn't want to do it, so this is just an op, right? Just takes the frame. I don't think this is I mean, theoretically this if I really wanted, but I think I can't even do that. Maybe I can, let's see. Yeah, so now they're like that, but that's a bit pointless. Anyways, so we have that. Now let's see if get Titan works. So okay, I have this and I can initialize, let's see. Formats cannot be empty. What's that? What? Is your representation an IO representation? Did I do anything here? I think I set up some crap that I didn't yet. Formats? Is your representation an IO representation? Formats cannot be empty. Oh, I need to set formats, obviously. Yeah, because yes, this is one of the issues. So in order for this to work, I need to say, okay, how do I store the data on the disk? So you can store it as numpy. Yeah, so this is the problem here. So this is formats. So I need to do something like this. Let's see. I think I can do this. Set parameters binary format equals. I think I can do this. And to be honest, I think this shouldn't be part of that. But this is like something you need to do. So let's yeah, self. Alright. Great. Alright, so I think this is all I need to do. Yeah. Okay, cool. So as you can see, there's a bunch of warnings, no compress, blah blah. Okay, so maybe I should fix that. Kind of. So I added this warning, so the config files work fine. So compress equals none. Actually, it was not. No, it was false. Image format equals not set. This should work. If it doesn't, okay, no device set. But this is just for okay, so output size, video shape. Output size equal video shape. Okay. This is fine. This makes sense to be generic. No device set. So that means I should do something like yeah, I just don't like those. Output size, batch size, so yeah, because it's not that one, it's set IO parameters. Okay. No batch size set, I mean fair. No output size, returning image, okay. Is that a problem though? Set IO parameters. better. Alright, no more warnings, great. So I have this debug crap. Alright, so that means I should be able to do log level equals 2 to get rid of this. So log level equals 0 actually. Yeah, this is a bit bugged, but I will fix it. Alright, so I have that. Nice. Running run. Do one representation. Yeah, I think it should be a debug. Now if I think about it. Yeah, it's much better now. Alright, is this all? Okay, now let's see what's going on with this part. So, line 55. Output images. Oh, because I put not set here. True, so output image is the E. Yeah, interesting. I think this function accepts nonce, hopefully. I don't remember actually. It doesn't. All images are none. Oh yeah. Alright, so that means I need to put here PNG maybe. Cool, so you get this output. You don't have any, okay, you have the keys, you have the numpy. I don't have any output images, and if I put PNG here, it should work. Is not known. It should be like this. Cool, and you get it finally. Okay, so that's not very streaming now, is it? No, you want it a bit faster. But hey, at least that's like display images. Let's display images res. It should be this text out, and it should just print stuff in frames. maybe not. VRE representations. You know what? I don't think I need any of this. Should be self-contained. Let's make it self-contained. Because I have representations are the keys for sure. Right? Point key, there you go. For I in rest recognized 0 key, and let's make sure it's ix actually. ix. For R in represents actually wait press the R. Alrighty. There you go. Now it's self-contained. Except it's not. Dict keys is not, because this needs to be list. There is the I. Okay, I just did here. There you go. Great. Cool. Yeah. I have predictions. Do it look like a different prediction? Let's put 100 and 1,000. Just make it 3,000. This is so slow. Oh, it's always predicting something. That's great. Alright. Working example with get item. Cool, so now I need to make get item 2, which is probably going to be more lines than this, because it's just calling a lot of existing stuff designed for batched inference, and make it streaming. Maybe I should do this if all basic output images is none. For R in remains lower print image format set not images word computed. Right. No images are computed. Skipping. That means we know that there is at least one. Maybe All right. If yeah, something like that. Now it doesn't break. Okay, cool. We have this, we have that. Let's move this actually a bit higher so it doesn't like obstruct us. Cool. So what we know. Okay, so I should have this, or at least I should have this part, but to be honest, I should have none of these parts. I'm not sure about if output size is actually an IO parameter or not. Anyway, let's try to do something. So get item 2. Trying to implement string without calling the batched, without wrapping the batched functions. Let's see if this gets us anywhere. So in theory, I should be able to do something like this. Res2 equals get item 2 with a trace for k in keys, set the rest of k equals rest of the k, rest of k, rest of the k. This should work, right? And if I do this, return with item 1, they will this crap. This should, in theory, work. I mean, I'll compute it twice, sure, but it should work. Alright. Oh, there's no truth value. This works. So why this works? Because this is supposed to be a repro out. And that's. I don't have an equal part. Oh, maybe it just tries to, since the data class. Yeah, I don't think that will work. Yeah. I want to do this. Q. This is mutual exclusivity, right? So that means 0.1 and 0 is fine, but this is not fine. So if this return false, I have memory data if self.output not equal to also. This is the hardest one, true or false, and should be the same for images. Says that output images is not on. Output images, output images, output is not known, and there is only correct. There is no those are not one of those are not. Okay, so this means I should be able to equal on them now. Yeah, it should now work. I should probably test there's no tests for that function. Test memory layout this is supposed to be for rep route equals data for it should be the same, but I add not here. Output images is okay. I think you're supposed to always put keys right here. Yeah, something like this. And now 5. Just change the key here. So it's very much different. R5. This work. Oh, R1 equals R2 is not true. I wonder why. It's supposed to be here. Somehow this doesn't work. extra. Oh, oopsie. You see, this is how you make tests. 4 equals 3. Oh, makes sense. I should change this. Great. That means I should be able to do this also, and it hopefully works now. Great. Test on repro out. So let's actually commit this. Let's do the Representations Extractor. String on, add basic script, add repro out equals checks, tests, and little use. Now wait a bit. Main problem with this is that the main problem with it's that I'm always supposed to mess a bit like the commit. Commit is a bit annoying. I have to wait for this. I don't know how to speed up this process. We're supposed to do some of these little hacks. Maybe I should just wait and maybe I should just wait and do many changes. So I did this script, but then I just did a bunch like tests and equals and some debugs. This will be a bit better later on, but let's say this skeleton code. I think this is fine.